Hello everyone and welcome to this tutorial session on Math with Ella. Today we are going to look at the June 2023 GCE question on theory of quadratics, that is advanced level, and the question was question 1 Roman 2. It reads, the roots of the equation 3x squared minus 7x plus 1 equals 0 are alpha and beta. Find the value of the expression 2 alpha plus 1 on beta, all of that plus 2 beta plus 1 on alpha. So we are going to solve this GCE question right away. But before we start, we have to recall that given the general form of a quadratic equation ax squared plus bx plus c equals 0, the sum of roots is given as negative b on a, where b, of course, is the coefficient of the x term and a is the coefficient of the x squared term, and the product of roots is c of a, where c is the constant term in the quadratic and a is the coefficient of the x squared term. Now, with that in mind, we can go ahead to solve our question on the theory of quadratics. So we start by writing out the equation we're going to be working with, that is 3x squared minus 7x plus 1, and we say the roots of this quadratic are alpha and beta. So first off, we have sum of roots SOR, that will be alpha plus beta. As we recalled earlier, negative b on a, our b here is negative 7, so negative b will be 7 on a, 3, and POR, product of roots alpha beta, would be equal to c on a, 1/3. Now we've been asked to find the value of this expression. We need to simplify that expression such that the terms in that expression will just be either alpha plus beta or alpha beta, so that we can use these values we've obtained, substitute it in there, and then we get the value of that expression. And we proceed as follows. So we need to simplify this expression. Let's start with the first bracket. We have 2 alpha plus 1 on beta. Simplifying this, we are going to have 2 alpha beta plus 1 on beta, that is looking for the LCM, and putting it as a single fraction. The second bracket there, we have 2 beta plus 1 on alpha. Putting this as a single fraction, we have 2 alpha beta plus 1 on alpha. Now, adding the two, we are going to obtain, so this plus this bracket plus this one will simply be this single fraction plus this single fraction, giving us 2 alpha beta plus 1 on beta plus 2 alpha beta plus 1 on alpha, and that's going to give us, we look for the LCM and do the arithmetic. Putting this into a single fraction, we are going to have 2 alpha squared beta plus alpha plus 2 alpha beta squared plus beta, all of this on alpha beta. From here, from this step to this step, I've simply look for the LCM, and then you do the way we normally do it. You divide and then you multiply by numerator, plus you divide and then you multiply by numerator, and then you're going to obtain this. Now we continue with the simplification. We are already almost there because we are beginning to see the kind of things we want to see. Remember, we want to see just alpha beta or alpha plus beta, because those are the expressions we know the value for. Now let's continue to simplify this. So we have 2 alpha squared beta plus 2 alpha beta squared plus alpha plus beta, all of this on alpha beta. So from here to here, I've simply brought this 2 alpha beta squared closer to this 2 alpha squared beta, and then alpha plus beta, I've put them here close to each other. We already have alpha plus beta here. We already have alpha beta here. Now we need to do something with these first two terms, and what we need to do is simply factor out 2 alpha beta, because when we look in this first term, we are going to see 2 alpha beta, and in this second term, we see 2 alpha beta. So factoring out 2 alpha beta here, we are going to be left with alpha plus Factoring out 2 alpha beta here, we're going to be left with beta plus, of course, alpha plus beta, which we already have there, on alpha beta. So looking at this expression, this simplified form of the expression, we have 2 alpha beta into alpha plus beta on alpha beta, and we already have values for all of these, so we just need to plug them in there and then we simplify. So from here we had alpha plus beta as 7 on 3 and alpha beta as 1 on 3. So we just substitute. Let us call this 1. Let us call this 2. And let us call this 3. So substituting 1 and 2 into 3, we're going to obtain 2 alpha beta. So alpha beta is 1/3 from 2. So we have 2 into 1/3 times alpha plus beta from equation 1 is 7 on 3 plus alpha plus beta from equation 1 is 7 on 3. All of this on alpha beta from equation 2 is 1/3. That's going to give us, this is 14 on 9 plus 7 on 3. All of this on 1/3. Simplifying this fraction right here, we are going to have 35 on 9 divided by 1/3, and that is going to give us 35 on 3. And that is the value of the expression 2 alpha plus 1 on beta plus 2 beta plus 1 on alpha as expected in the question. Thank you so much for watching. I hope you've learned, and please do consider following our page, and until I come your way again, remain blessed.